Hey everybody, Longo here, and in this video we are going to cover parabolas, but not the parabolas you guys are used to. Still the same thing, but we're going into more detail, and we are going to have different, shall I say, directions these things can go. Currently you're probably used to just up and down, but they could also go left and right. And yeah, we're just going to have some fun here. Okay, so you are used to y is equal to x squared as a parabola. But what you can really do is you can have y squared be the parabola as well. There's also going to be a 4a, which is going to give us certain information. So the general form of a parabola for now is going to be x squared is equal to 4ay. But if that only means that the vertex is at the origin. If you want a vertex, it's still h and k like it used to be, but now we have our h and our k inside parentheses, and notice our x is squared. When x is squared, it's going to open up if the a value is positive, and it is going to open down if it is negative. That's kind of similar to what you already know. But if you switch over to this side, we have y squared over here, which means it's going to open to the right if it's positive, and then it's going to open left if it's negative. H and k is still going to give you the vertex. Notice that if you have the y on the left, you are going to have your k value inside with the y, and now your h is on this side. But those are just all the different things that happen when you work with fancier parabolas. Vertex, still h and k like it always was. After you find a is the distance to the focus and directrix from your vertex. This is similar to like finding the distance to a focus from a hyperbola or an ellipse. That was c. This you only have one focus because you only have one part of a graph. The parabola is just going to open one direction, unlike a hyperbola or two stretched parts on an ellipse. And outside, though, you have a line that is perpendicular to what would be your axis of symmetry, and that is the same distance outside of the parabola that your focus is inside. That's why we use a for both. Now, the latus rectum is just the width of the parabola at the focus point. And we're going to find that by just using the absolute value of the 4a, and that is going to tell you how far or how wide the parabola is, and we will do a little bit more with that in a bit. So just like everything else, it's easier if you just see it done. So we're going to start off with graphing something. And there's a few things that you might want to think about first. Number one, x is squared. Our 4a value is negative. This parabola is going to open down. Okay, it's good to just think about that right off the bat, because that's going to help you list your focus and directrix. And it's also going to help you with your latus rectum. So what is our vertex? H comma k, so opposite of what's inside of the x and y, so our vertex is going to give us negative 1 comma 3. And I would recommend that as you find your stuff, you go plot it. So we have a negative 1 comma 3, that's our vertex. So now we have to find our a value. So if you go back to the original general form, we have 4a, and that's what's before here. So 4a is equal to a negative 4. Divide both sides by 4, and we know our a value is a negative 1. Now, does the negative really matter? Not much. We know we're going to be opening down, so negative 1 would say that we're going down 1, and then a positive 1 would go up 1. But as I mentioned, if you just think that the focus always has to be inside the parabola, that's much easier to work with than a positive and a negative. So our focus is going to be 1 unit inside the parabola from the vertex. Since this is opening down, your focus is 1 unit down, which puts us at -1, 2. Now your directrix goes in the opposite direction. So the directrix is going to be 1 above your vertex. But again, a directrix is a horizontal line. So that's going to be at y equals 4. Okay? So that is where you find that information in terms of what the A does. But again, it's easier to just think about opening up, down, left, or right. Now your latus rectum, that's another new piece. This entire value is -4, but it's the absolute value of that. So your latus rectum is 4. That means the width of this parabola at your focal range is 4. That means you have 2 in each direction. If you were to just split that. So we're going to go 2 to the right, and we're going to go 2 to the left of the focus, not your vertex. And that tells you how wide it is at that part. So now, all you have to do is follow those points, draw your parabola, and you're good to go. So, again, it's got more information than what you're used to. You are already used to the fact that a negative x squared is going to open down. We've done some stuff with the focus, so we're just doing things a little bit different than we did before. But again, it's not too bad. So next example, we are not in graphing form. So just like ellipses, circles, and hyperbolas, you've got to put it in graphing form first. This one's a little different because, again, go all the way back to the beginning. We are going to put the squared variable on one side and the rest of the information on the other. A little bit different. So we're going to have y squared minus 2y is equal to 12x minus 25. Half of -2 is a -1 squared is a +1, so we're going to add 1 to both sides. So now on the left we have y minus 1 squared is equal to 12x minus 24. But to get that 4a value out front, all we have to do is factor out a GCF. Our graphing form for this is y minus 1 squared is equal to 12 times x minus 2. And now we're in graphing form, ready to go. So our vertex is at 2, 1. You have to be careful of where you're getting your values. The x came from this side now, so we're at 2, 1. Our a comes from 4a is equal to, in this case, 12. Divide both sides by 4, so a is equal to 3. So now we have to think, where is this parabola going to open? Well, our y variable is squared, and we have a +4, which means this guy's going to open to the right. Another way to think of it is we have a positive x. We know x goes positive in the right direction. So, a couple of ways you can think about it. So, if we have an a value of 3 and our focus has to be inside the parabola, we are going to go 1, 2, 3 units to the right. That is where your focus is. So your focus is at 5, 1. Which means your directrix is in the opposite direction, which means 1, 2, 3 units to the left. But again, it is a line, not a point. So a vertical line is at x equals -1. Now we kind of know where we're graphing, but the last thing we need to find is how wide it is at the focus. And that is your absolute value of your 4a. So the absolute value of 12 is 12. So your latus rectum is 12, meaning you're going to go 6 in each direction. So you're going to go 6 up, and you're going to go 6 down. And I plotted those on the wrong spot because you're supposed to do it at the focus. So 6 up and 6 down. And now your graph is going to look like this. Big old parabola opening to the right. So that's parabolas. Again, a little different. I know we've kind of changed some things on you, but if it's very similar to everything we just did with ellipses and hyperbolas, just knowing which direction things are opening, where to put your focus, use a little bit of math in terms of finding an A or a C value, and that's it. So anyway, that's it for parabolas. This is Longo, and I'm out. See you, bye.